Assalamu alaikum students. So today we are going to start the chapter of stoichiometry. So first of all we will see how to write the chemical formula. A chemical formula represents the number of atoms of different elements which are present in a molecule. For example, if you see this first one, the formula for water, here you can see that there are two elements present. One is hydrogen, the other one is oxygen, and there are two atoms of hydrogen combined or bonded with one atom of oxygen. Whereas in carbon dioxide, you can see that there are two elements, carbon and oxygen, and two atoms of oxygen are bonded with one carbon atom. In a molecule of hydrogen, there are two hydrogen atoms covalently bonded together. In a molecule of oxygen, there are two oxygen atoms, whereas in the molecule of nitrogen, there are two nitrogen atoms. Now, after that, you can see that in the periodic table, I have shown you the simple ions and the charges, the oxidation numbers which are present on these simple ions. For example, all the elements belonging to group 1 have the oxidation state of +1. Group 2 members have oxidation number +2. Group 3, group 4, group 5, group 6 and group 7. For group 8 it's 0 because their outermost shells are complete. These ions are called simple ions, and while writing the name of any salt, a salt has a positive and a negative ion both. So first of all, when we write the name, we always write the name of the positive ion followed by the name of the negative ion, and when we write the name of the negative ion, we have to end it by writing IDE in the end. For example, sodium chloride, we don't write it sodium chlorine, we write it sodium chloride. In the end we have to write IDE. Calcium oxide, we don't write calcium oxygen, we write calcium oxide. Besides these elements, we have some transition elements having variable oxidation numbers like iron, copper, chromium, manganese, lead, silver and zinc. They have more than one oxidation numbers. Along with that, we also have some complex ions. These complex ions are polyatomic ions having more than one atoms combined together, and you can see the oxidation numbers which are present on these complex ions. Now we are going to use these simple ions, complex ions and these transition elements having different oxidation numbers to write the formulas of different compounds. Like first, the most simple one is sodium chloride. Sodium belongs to group 1. So what would be the charge on sodium? It would be +1. Chlorine belongs to group 7. So group 7 has a charge of -1. +1, you can just understand it like this, that +1 will balance -1. They will both balance each other. The formula would become NaCl. Then the next one is magnesium oxide. Now magnesium belongs to group 2, so it would have a charge of +2. Oxygen belongs to group 6, so it should have a charge of -2. Again, here you can see that both these charges balance each other. +2 will balance -2. So the formula of magnesium oxide would be simply MgO. And here you have ammonium ion. You can see over there the charge which is present on ammonium ion is NH4+, whereas chlorine has a charge of -1. Again, they will both balance each other. The formula of ammonium chloride would be NH4Cl. Now let's move on to sodium oxide. Here sodium belongs to group 1 having a charge of +1, whereas oxide means it's oxygen. Oxygen has a charge of -2. Now these two charges do not balance each other. So what do? We write these numbers over here. For sodium it is 1 and for oxygen it's 2. Now swap these valences, these numbers, and write them as their subscripts. So what would be the subscript of sodium? It would be 2. And What is the subscript of oxygen? It would be 1. Then the next one is aluminium oxide. Aluminium has a charge of positive 3 and oxygen is negative 2. So just write these numbers over here and swap them and then write them as their subscripts. The subscript of aluminium would be 2 and of oxygen would be 3. So it shows that in the formula there are two aluminium atoms, or there are 3 oxygens. And then calcium belongs to group 2, so it has a charge of positive 2. Phosphide means it's phosphorus belongs to group 5, so it should have a charge of negative 3. Now write 2 over here, 3 over here, swap them and write the formula. Here you have calcium 3 times calcium and 2 atoms of phosphorus. Alright, so this is how you write the chemical formulas of simple ions. So we are done with the simple ions. Now let's take some complex ions. For example, sodium sulfate. Sodium is a simple ion belonging to group 1. Its oxidation number is positive 1, whereas sulfate is a complex ion and the charge or the oxidation state on sulfate is negative 2. Just write the valencies at the bottom and then swap them. Here what would be the formula? The subscript of sodium would be 2 and for sulfate it is 1. The subscript is 1. So the next one is calcium nitrate. Calcium belongs to group 2, so it has a charge of positive 2, whereas nitrate is a complex ion and it has the oxidation number of negative 1. So again, what should we do? We will write 2 over here, 1 over here. Now just swap these numbers, but over here just see that the subscript of calcium would be 1, so just write calcium over here, and then nitrate is being multiplied. We have to write 2 with nitrate. Now nitrate is a complex ion, so whenever you have any complex ion and you have to multiply it with 2, 3 or any bigger number, just put them inside the bracket and then write that number as a subscript. Okay. Now next one is ammonium sulfate. Ammonium is a complex ion and it has a charge of positive 1. Sulfate is also another complex ion having a charge of negative 2. Just write 1 over here, 2 over here, swap them and write these numbers as the subscripts. Again, the subscript of ammonium would be 2. So it's better to put it inside the bracket. NH4 whole twice and then SO4. Then for transition elements, as they have variable valencies, they have more than one oxidation state, so their oxidation state must be mentioned in their formula, in their names. Okay, so like it's written iron 2 chloride. Iron 2 means it has a charge of positive 2 and chlorine has a charge of negative 1. Write 2 over here, 1, swap them, and the formula for iron 2 chloride would be FeCl2, whereas for iron 3 chloride, now we have Fe3 and chloride. Here it will be 3 and 1, so the formula would become FeCl3. All right. After that, we have to see how to balance the equation. For balancing equation, I have selected these few examples. Like first reaction is between magnesium, that magnesium burns in oxygen to form magnesium oxide. It's a combustion reaction. Sorry, not a it's magnesium burns in oxygen to form magnesium oxide. The word equation is given over here. You can see magnesium plus oxygen giving magnesium oxide, and then we can write the simple equation for that. The symbol for magnesium is Mg, for oxygen it is O2, giving you magnesium oxide. Now first of all you have to see, okay, what's the formula for magnesium oxide. Magnesium belongs to group 2. It has a charge of positive 2. Oxygen belongs to group 6, having a charge of negative 2. So they will balance each other, and then the formula would be MgO. Alright, but when you see this equation doesn't seem to be balanced, because over here we have one magnesium atom and over there we have one magnesium. So magnesium is balanced. But if you see the oxygen, there are two oxygen atoms, and over here we have one magnesium atom. So while after writing the simple equation, we need to balance that equation. Alright, so for balancing, I have written few rules for balancing as well. While writing a balanced equation, the most important thing is that we have to mention the state symbols as well. For anything that is present in solid state, we have to write the small s as a subscript. For liquid, we write L. For gas, we write G. And for aqueous or any for the solutions, we have to write AQ. For balancing, we have to follow certain rules that will make our balancing much easier. So first is that write the correct formula of all the reactants and the products. Make sure that the formulas once you write for the products and the reactants, they must be correct. Do not change the subscripts. Once you have written the formula, for example, if you have written the formula of water H2O, it should remain H2O. You will never change these subscripts. You will not write it while balancing that, oh, I need only one hydrogen, so I'll put water like this. This is not water. Alright, so you will never change any subscript given in the chemical formula. Then balance one element at a time by placing coefficients in front of the formula. Like, if you have to balance, you will not change the subscript. In any case, you will not change the subscript, but you will write the numbers as coefficients over here. Like if we need 4 hydrogens or 2 oxygens, write these numbers over here as coefficients in front of the formula. You will not make it like this. This is not the correct way. All right. And if polyatomic ion remains unchanged on both the sides, balance it as a whole ion. By polyatomic ion, we mean complex ions like nitrate, sulfate. Treat them as one single unit. Alright, if they remain unchanged on both the sides of the equation. Next is that what should be the order that you follow while balancing the equation. Try to balance the metals first, then the non-metals, then hydrogen, and in the end goes oxygen. That will help you in balancing, and it will make your balancing much easier. Alright, now let's come back to balancing. Over here we have one magnesium atom. It's present in solid state. It's magnesium metal. It's oxygen gas. So we'll write small g over here, and then it forms magnesium oxide, which is again a solid. So I'll write S at the bottom as subscript. Now I need to balance it. First of all, I'll see that the metal magnesium is balanced. Next I will check oxygen. Oxygen, there are 2 oxygen atoms on the reactant side, whereas 1 oxygen atom in the product side. So if I write 2 over here to balance oxygen, see, I have not written 2 over here as a subscript. That would be incorrect. It would change my formula. So I've written 2 over here as a coefficient. Now that that balances oxygen, but now the number of magnesium on product side has increased. So I will write 2 over here as as a coefficient instead of writing 2 over there as a subscript, you will not do it. Okay, so just while balancing, you have to write these numbers as coefficients, write them in front of these formulas, not as the subscript. The next equation is that zinc reacts with hydrochloric acid to produce zinc chloride and hydrogen gas. The word equation is given and we have to write the symbol equation for that. The symbol for zinc is this, and HCl, the formula of HCl is H, hydrochloric acid is HCl, zinc chloride. Now I have to make sure that my formulas are correct. So zinc has a charge of positive 2 and chlorine has a charge of negative 1. That makes the formula to be ZnCl2. So I will just write the correct formula. After writing the correct formula, then I will go for balancing. And for hydrogen, is hydrogen gas, it's a diatomic gas, so I'll write H2. Okay, now I have to balance this equation. Over here the metal is zinc. I'll first try to balance zinc. Zinc is balanced. Then I'll see chlorine. Chlorine ko I need to balance first. Here we have 1 chlorine and over there we have 2 chlorine atoms. So I can write 2 over here to balance chlorines on both the sides. Chlorine is balanced. And what about hydrogen? This all, by writing 2 over here, the hydrogen itself gets balanced. And now I just need to write their state symbols. Zinc is a solid metal. HCl is dissolved in water, it's aqueous solution. Zinc chloride is soluble in water, so it will form aqueous solution, and hydrogen is a gas. Okay, now next is the reaction of lead nitrate with potassium iodide. So before writing that equation for this reaction, I need to know the chemical formulas for zinc, for lead nitrate and potassium iodide. Lead nitrate, lead 2, that means it has a charge of positive 2. Nitrate is negative 1. So I'll just swap these numbers and write the formula as PbNO3 whole twice plus potassium iodide. Potassium belongs to group 1. It has a charge of positive 1. Halogens have a charge of negative 1, so they will both balance each other. So the formula for potassium iodide would be Ki. Now when the reaction takes place between them, the product would be this lead will combine with iodine to form lead iodide. Now again, lead has a charge of positive 2, iodine has a charge of negative 1. So that what would be the formula for lead iodide? It will be 2, 1, cross them and then write the formula. It would be PbI2 plus potassium will react with nitrate. Potassium has a charge of positive 1, nitrate has a charge of negative 1, so they will both balance each other, and I will get the formula for potassium nitrate. Alright, now I need to balance this equation and I have to write the state symbols as well. So for balancing, I'll see the metal is lead and it's balanced on both the sides. Potassium is also a metal, potassium is also balanced on both the sides. Then I will see the non-metal, which is iodine, which is not balanced on both the sides. Here on the product's reactant side I have 1 iodine, on the product side there are 2 iodine, so I need to balance iodine. If I write 2 over here, now the iodines are balanced on both the sides, but this makes writing 2 over here makes potassium more on the reactant side. To balance potassiums, I need to write 2 over here. with potassium. All right, now I'll check nitrate. Nitrate, I'll take it as 1 unit. I will not break it into nitrogens and oxygens and separate them. No, I will take it as 1 unit. So over here I have 2 nitrates over here, and 2 nitrates are also over there. So I think now the equation is balanced now. Now the next one is aluminium sulfate. Aluminium sulfate, again write the correct formula. First of all you need to write the correct formulas and then we'll do the balancing. This is sulfate. So that makes the formula of aluminium sulfate as Al2, and we should write sulfate inside the bracket because it has to be multiplied with 3. The subscript is 3. Then sodium hydroxide. Sodium hydroxide, NaOH. Sodium has +1 charge on it and OH hydroxide group has -1, so they both balance each other. Now let's see what are the products that will be formed. Aluminium will react with hydroxide to form aluminium hydroxide. Aluminium has a charge of +3, hydroxide is -1, 3 and 1 just swap them, and see aluminium will react with OH and sodium would react with sulfate. So what would be the formula now? It would be Al and put OH inside the bracket and write 3 as the subscript. Aluminium hydroxide plus sodium sulfate. Sodium is this and subscript of sulfate you'll write it as a subscript and sulfate. Now we have just written the correct formulas and we need to balance it now. Just check the metals first and non-metals and keep the sulfates intact. Now aluminium, there are 2 aluminiums, there's 1 aluminium, so write 2 over here to balance aluminiums. Then check sodium metal. Sodium, there is 1 and there are 2 sodium metals, so it's better to write 2 over here to balance sodium. We are done with the metals. Now check the non-metals. First of all, in non-metals we can check the sulfate ions first. Here we have 3 sulfates, but over there we have just 1 sulfate, so we can write 3 over here to balance the sulfates. But now if we write 3 over here, that makes sodiums 6, so I should write 6 over here to balance sodiums. 6 sodiums on both the sides. Now let's see the hydroxide groups. Because aluminiums are balanced, the sodium ions are balanced, sulfates are balanced. Now we are just left with hydroxides. Hydroxide is also balanced now. Okay, 2 3s are 6, so hydroxide is also balanced. So that's how we do balancing of equations. Now next topic is the relative atomic mass. It means that a relative atomic mass of an element is the average mass of the atom of the element compared with 1/12 of the mass of one atom of carbon-12. The relative molecular mass of a substance is the average mass of one molecule compared with 1/12 of the mass of one atom of carbon-12. Alright, now relative atomic mass. For this when we have to find out the atomic masses of atoms, since atoms are very small, it's not easy to weigh each and every atom and find its mass. So how is it done? We take the relative masses, means we compare it with a standard with some standard element. And what is standard? What have we taken standard as a reference? We take carbon-12. Alright, with carbon-12 we can compare other elements. For example, we are comparing with 1/12 of the mass of one atom of carbon-12. That means that if you divide the mass of carbon, which is 12, and you divide it into 12 equal pieces, one small part will represent 1 unit. All right. Now you compare carbon. You can compare carbon with other elements. For example, if I put carbon atom over here, just imagine it like we are balancing in a balance. This is one carbon atom. All right. So for one carbon atom having a mass of, we said, just 12, on the other side, if I put hydrogens in it, hydrogen is a much lighter element, and I see if I have to put 12 atoms of hydrogen to balance this one atom of carbon. So that means that what would be the mass of one hydrogen atom? It would be 1. So AR, we have just compared hydrogen with carbon, and we have seen that hydrogen is lighter, and hydrogen is 1/12 the mass of carbon 12. So the mass of one hydrogen atom would be equal to 1. All right. In the next example, we can take example of let's say magnesium. Now here, if I just take one carbon atom and put magnesium over there, magnesium is heavier as compared to carbon. So in order to balance this magnesium, I need to put one carbon atom more. So that makes the relative atomic mass of magnesium to be 24. So that means that magnesium is about 24 times heavier than 1/12 of carbon 12. Alright, that means we have divided 1/12 of 12 is 1. It's 1 unit. I hope it's clear now. And you see that both these values are these relative atomic mass, relative molecular mass, these are relative values, and they do not have any units. So this average, the average mass of the isotopes, the average of isotopes plus that we compared it with carbon 12, that gives us the relative atomic mass. All right. So that is why we just said that relative atomic mass is the average mass, average of all the isotopes, and then we take the average of it, average mass of the isotopes of that element, and then we compare it with 1/12 of the mass of carbon atom, and we get the AR values, and these values do not have any units. All right. Now let's calculate the MR, relative molecular mass of different elements. And what's the formula? How can we get the molecular mass, relative molecular mass? The formula is that you take the AR of the first element, multiply it with its subscript, then add it to the AR of the second element, which is also multiplied by the subscript. Then the same goes on for third or fourth elements. All right. So we can do it, we can understand it with the help of example. First is of calcium carbonate. I have written the AR of calcium is 40. Okay, it's 40. The subscript of calcium is 1 plus its carbon. Again, the subscript of carbon is 1. So we'll write 12 multiplied by 1 plus the AR of oxygen is 16, but the subscript is 3 now. So when you multiply all these numbers and then add them, you will get the answer, and it would be 100. MR of CaCO3 is 100. The next element, the next compound I have written over here is ammonium. sulfate. So for calculating the relative molecular mass of ammonium sulfate, this ammonium is multiplied by 2. So write 2 here outside the bracket, and then inside the bracket write the AR, atomic mass of nitrogen, which is 14. The subscript is 1. Alright. AR of hydrogen is 1, but the subscript is 4. Close the bracket. Plus then we have sulfur, so which is 32, plus oxygen, which is 16. The subscript of oxygen is 4. Then you solve the bracket, multiply it with 2, and then you will get the MR of ammonium sulfate to be 132. See, I'm not using any units. Next is copper sulfate with 5 water molecules. This is a water of crystallization. So we can calculate the mass of MR of water. First of all, MR for water, it is hydrogen is 1 multiplied by 2 plus oxygen is 16. So that makes 2 plus 16. The MR of water is 18. Alright. Now the MR of hydrated copper sulfate would be AR of copper is 64 plus 32 for sulfur plus 16 for oxygen multiplied by its subscript, which is 4, plus 5 multiplied by 18 for water. Then you can solve it, and I think your answer would be 250. Alright. Now the next topic is percentage composition. The formula for finding the percentage composition of an element is written over there. It's like you have to multiply AR of that element with its subscript divided with MR, the relative molecular mass, and then multiply it with 100. So here's the question that calculate the percentage of nitrogen in ammonium sulfate. So for that we need MR, and we have just calculated the MR of ammonium sulfate. Above we have, over here we have calculated it. Here its value is 132. Alright, just write the values over there in the formula. Percentage of nitrogen would be, the atomic mass of nitrogen is 14, AR for nitrogen is 14, and its subscript is how much? Its subscript is 2 divided by 132 multiplied by 100. So this is how you can calculate the percentage of any element in its compound, and it would be 21.21%. Now the last topic is that how to calculate the mass of an element in the compound. Means you're not given the percentage, it's not out of 100, but you will be given some mass. Alright, so again the formula is there. Mass of an element is equal to its relative atomic mass multiplied by its subscript divided by MR, and now you have to multiply it with the given, whatever the mass is given to you in the question. So in the question it's written that calculate the mass of iron in 15 gram of Fe3O4. So first of all we need to calculate the relative molecular mass of Fe3O4, and it would be, atomic mass of iron is 56, so that means that it would be 56 multiplied by 3 plus 16 multiplied by 4, and we'll calculate it. It would be 232. Now you can use this formula, write the values. You have to find out the mass of iron. Mass of iron, and its atomic mass is 56. Its subscript is 3, divided by mr, we have just calculated it now, multiplied by what is the mass given. It's given 15 gram in the question, so it's multiplied by 15. Just do your calculations, and I think your answer would be 10.86 gram. So this is how you'll do the calculations. I hope you have understood the concept. Okay, Allah Hafiz. See you next time. Allah Hafiz.